Today we're going to be talking about the Pythagorean Theorem and its converse. Our objective is that we will use the Pythagorean Theorem to find the lengths of sides of a right triangle and use the Pythagorean converse to classify triangles as acute, obtuse, or right. Recall that the Pythagorean Theorem is c squared equals a squared plus b squared. The hypotenuse is the longest side and is represented by the letter C. It's always going to be the side across from the right angle because the right angle is the biggest angle, and that's across from the longest side. The other two sides are referred to as legs. And the legs are what we plug in for A and B, and it doesn't matter which one is which. So let's put this to use. We're going to find the value of x. Since x is across from the right angle, that's going to be our side C. So x squared equals 12 squared plus 16 squared. If we type 12 squared plus 16 squared into our calculator, we get 400. To undo the square, we would square root both sides, which would give us that x is equal to 20. This time, we know our hypotenuse. We're trying to find one of our legs. So 6 squared equals x squared plus 2 square roots of 2 squared. 6 squared is 36 equals x squared. Now squaring this looks a little scary, but we can use our calculator for it as long as we're using parentheses properly. So parentheses 2 square root 2, then we're going to arrow out of the square root and close our parentheses, and then squared. And the calculator knows what to do with that, and it is 8. So plus 8. We need to get the x squared by itself, so we subtract 8 on both sides. We get 28 equals x squared. Again, we're going to square root both sides to undo the square, and we get that x is approximately 5.292. In this one, it wants us to find x, but we don't know this side of that triangle. So I'm going to label that y, and we're going to need to find that first. So we're going to use this triangle here, and I'm going to highlight in pink. We're going to use that triangle first. So the 25 is across from the right angle, so that's C. So 25 squared equals y squared plus 24 squared. 25 squared is 625 equals y squared plus 576. Subtract 576 on both sides. And we get that 49 equals y squared. Square root both sides. And we get that y equals 7. So now we can find x squared using this triangle, now that we know that this side is 7. So the C is the one that's, the x is the one that's across from the hypotenuse, so that's C. So x squared equals 26, or square root of 26 squared plus 7 squared. Bring down our x squared. Square and square root undo each other, so this would be 26 plus 7 squared is 49. So x squared equals 75. Square root both sides, and we get that x is approximately 8.66. This one's a little different, but it's the same idea. Find the length of the diagonal of the square. So it wants to know from here to here, and I'm going to label that x. So all it's saying is do the Pythagorean theorem with this triangle here. We don't have to worry about the other half of the square. C is across from our right angle. So x squared equals 5 squared plus 5 squared. 5 squared is 25. 25 plus 25 is 50. Square root both sides to undo our squared. And we get that x is approximately 7.071. So that's if we know it's a triangle. Sometimes we're going to be given the sides of a triangle and try to figure out if it's a right, acute, or obtuse. So, if c squared equals a squared plus b squared, then the triangle is a right triangle. So if they're equal, it's a right triangle. But what if c squared is less than a squared plus b squared? Then it's acute. Acute is smaller than 90 degrees, so c squared is smaller than the other sides squared. Obtuse would be if c squared is greater than the other two. So let's look at some examples. The first thing you need to figure out is which side is going to be c. It's going to be the biggest side. So in this case, 8 would be our c. So we have 8 squared. We don't know if it's equal, less than, or greater than. 7 squared plus 2 squared. 8 squared is 64. 7 squared is 49. Plus 2 squared is 4. 64 compared to 53. That means that 64 is greater than 53, therefore this is an obtuse triangle. Here, square root of 4, square root of 6, square root of 5. Square root of 6 is going to be our largest, so square root of 6 squared compared to square root of 4 squared and square root of 5 squared. Remember, square and square root undo each other, so this would be 6 compared to 4 plus 5. 4 plus 5 is 9. 6 is smaller than 9, so this is an acute triangle. In this one, you probably don't know what the square root of 56 is off the top of your head. Square root of 56 is a little bit more than 7, so that's not our biggest side. 9 would be our biggest side here. So 9 squared, how does that compare to 5 squared plus square root of 56 squared? 9 squared is 81. 5 squared is 25. Square root of 56 squared is just 56. How does 81 compare? 25 plus 56 is 81. So since they're equal, it is a right triangle. Our last example is a word problem. Jake plans to use a ramp to make it easier to move a piano out of the back of his truck. The back of the truck is 33 inches tall and the ramp is 65 inches long. What is the horizontal distance from the end of the ramp to the back of the truck? So we know that the truck, from the ground to the top of the truck, is 33 inches. The ramp coming off the truck is 65 inches. We want to know how far it is from the edge of the ramp to the back of the truck. So that right there. So this would be our right angle. So across from it, that's our C. So 65 squared equals x squared plus 33 squared. Using my calculator, I found that 65 squared is 4,225 equals x squared, plus 33 squared is 1,089. Subtract the 1,089 on both sides. We get 3,136 equals x squared. Square root to both sides to undo the squared. And we get that x equals 56. Since we're dealing with a word problem, we should include our units in our answer, which would be inches. That's all for today. Fill in your summary.